best commercial instrumentation of GPS on this expensive ship, and no one aboard can detect that it's happening. Well, I'm in the commercial business of preventing oil spills from either navigation or collisions or whatnot. This to me, particularly since in the last couple of months, in the open press and so forth, there's been thousands of jammings, not spoofings yet, but of GPS from the North Koreans. And what I'm doing about it, because I don't think the Air Force or the government will do anything about it. This is one threat that you can just take off the table on GPS. You can't touch it if you combine GPS and LORAN. And you fix that by just buying and when I was doing this, $700 receivers, which are GPS LORAN that would do the job. And I think my best advice is just warn ship owners to just go to spend $600. It's too hard to convince the government, as we're finding today, to do anything, much less nullify completely a threat and get all its other benefits. Like in military use, I was pointing out in this video, it's 20 times more accurate than a compass for targeting, and using itself as it was done in Laos. And that's important because just recently I see that we really bombed Laos with more tonnage than Japan and Germany together. This was something Obama just blurted out recently. So this putting LORAN in is becoming more and more important. And I really don't have an axe to grind in. It's just that I have studied it for 15 years, and there's really something to it. I frankly, even GPS people should be welcoming LORAN, LORAN. But anyway, that isn't what I started to talk about.
No, but somehow, Jack, I knew you were going to go there. Let's hear about three-axis stabilization.
I'm going to go there. So
how you came up with that in about 1955.
Okay, yeah. Starting in 55, there's a video that you can get to. Go to automate.com/space, and you can target. There's 2 or 3 links on that subject, so you get the old history. What I thought today, I talked about something that would complement that wasn't available 13 years ago. And the LORAN thing is part of it. I won't do that again. One interesting thing that's related to the militarizing of space, and I'll go back to the Corona program, that I actually started on that in 55 because it was at MIT, and I had to do a thesis. And at that time, Draper had contracts in what's called the MIT Instrumentation Lab. It's now called Draper Lab. But anyway, the contracts were for ICBM guidance, and we were starting out with a thing called Skipper, was the Atlas, which didn't turn out to be inertial. Titan, I think there were several versions of it. Titan 2 or so became all inertial through Draper Lab. And they even did things for the Navy, like the submarine inertial system, which was a 2,000-pound IMU. It was huge. And just to make sure, they voted 2 out of 3. So there was a 6,000-pound, 2 out of 3 voting IMU on subs. So the idea started from what we're going to do, because the mission contract they had was to do guidance and stabilization for satellites, for military purposes, for reconnaissance. And the basis of that was the RAN studies, and Bob Salver, I think, happens to be sitting next to me during that 2003. We worked very closely to RAN to implement that. And just to pick on the point here, we did this after I got my degree. I had done that based on using the SINs, because the father of SINs was there, Joe Delisle, in Draper's lab. The idea was to take one of those SINs, 2,000 pounds, and shrink it to 200 pounds. The idea being we were going to use a principle that Draper often used, which is called synergism, and you almost never hear that word anymore. And synergism, as Draper used to explain it, was if you take 2 concepts that almost solve a problem perfectly, if you mix them, combine them in some clever way, you're always going to find they're better than either one. And there's my LORAN pitch in a one-liner. But anyway, that was the concept for SN guidance. the concept for stabilization was something that Rand had the original idea. We merely implemented it. It was essentially have a dumbbell, and we actually made one to take around to briefings for Secretary of the Air Force in, because they say, how does it work? And the basic principle, we would have a rod with a jewel bearing and a sort of a weight on either end, a sphere. And the idea is that the center of mass and the center of gravity are not exactly alike. So if you spun this thing around, you would see it would sort of wiggle around. And what the approach for damping was to essentially have a rate gyro, and as you see it going this way, you cancel it with a momentum wheel. So it was gravity stabilization with merely a damping system. Excuse me a second. And of course, at the briefings, people would ask, how do you know that will work? And of course, we would point to the moon, because you always see the face of the moon facing the Earth. And for a reconnaissance camera, it turns out we later found that that's really what you want. But the original Air Force system, which was 117L, we did it right, Pat. And then, oddly enough, we were transferred to Los Angeles. I think I was the 40th one there, the only one less than a major at that time. But anyway, when Colonel King transferred it, Bob Truax, a Navy captain at the time, was on loan from the Navy because they weren't doing missiles, and General Schriever barred him, although he always thought he was a spy. I think it's the thing he used to say. But anyway, Bob was there, and Colonel King at the time was where I was assigned to Wright Pat with Coolbaugh and Tretchell, other pioneers here. We were known as the Space Cadets, and Bill King had an outfit that made jewelry, make us a little pin that was essentially representing a 83-degree retrograde orbit, which at 300 statute miles was what was required to have a constant illumination for visible satellites. All year long, the plane would rotate around if it was that. So this was an unclassified little club we had among the three of us, and Space Cadets was a very negative term. I'm laughing about it now, but it wasn't so funny. But anyway, we were transferred to from Wright Pat. Bill King went to brief General Schriever about what he was transferring, the program characteristics and what it needed. So we already know what we want. We've already picked a rocket engine, the Hustler, which was a Bell aircraft, 15,000 pounds, that had the kind of fuel. Truax was a real expert in rocketry. That's what he wanted. When we did system contracts and studies, we didn't want any other answers. We knew what the hell the answer was. And similarly, because of MIT having all the background of doing almost all the inertial systems, and ironically, they were done with gyros that were flotation. And it turns out later, as we'll get into it, North American, who worked on the RAND programs, was very qualified in many of the ways, except for one thing. The current versions of their platforms use gyros that were air bearings. And on a simple basis, it didn't seem like such a good idea going to space with air bearings or the development to switch over what Draper had been working on for years. So we were beginning to think sole source. And to make a point that was just made earlier, General King, in front of, it was Colonel then, he was an LC then, briefed General Schriever that we have some hard-on decision made. We don't need any help from Raymond Woolridge, your system contractor, on everything else out there, which is going along with what was just said earlier. He made it quite clear, and he said, General, if you insist on doing that, you're going to delay the program a year. And that was a nerve to say that, I thought. But anyway, let's see. Now back to some stories. Corona started by essentially getting me out of the Air Force. I owed them a 3-year payback. And the last thing I did was, and I think it was 3 months after Sputnik, we gave a briefing of the status of our own military satellites compared to what we thought the Russians might be doing or where they were. having succeeded already. By then it was almost launching dogs and whatnot. But I gave a briefing, and Killian was there, Lamb was there, etc. It was a very important briefing. Right after that briefing, I got a wire from personnel in headquarters ARDC. If you'd like to get out of the service early, you don't owe us a 3-year payback. And I said, oh, I'd like to get out right away. I got out and was hired by Dick Leghorn, starting ITEC, out of the Boston University Physical Research Labs, that had been doing high-resolution balloon cameras to fly at twice the altitude of the ones that had been, maybe 400 of them shot down or did no good, but by going twice the altitude, it was thought, and taking high-resolution pictures, and we were the first at 100 lines per millimeter. World War II, just for your information, was maybe 10 lines per millimeter. So that high altitude was useful stuff. And I worked on that on the navigation deck while we were getting the Corona proposal together. We proposed using the Agena because we found out that at that time the CIA already had taken a RAND recommended solution of the old project feedback RAND reports and do a spin stabilized satellite. And our argument for it was that at that time I had been working on the Air Force satellites, which were 117L, was a television system at 300 miles that was essentially gravity stabilized, as I mentioned earlier, or minus even higher altitude. And they worked there at high altitude. So when I got to work for Leghorn, he said, we want you to stabilize a scaled up balloon camera, panoramic camera, that goes back and forth with a high resolution telescopic lens. So it's a mechanical kludge on a roll axis of a vehicle that upsets the vehicle in an opposite way. And it was a tough job. I said, we can't do that. And he said, we also want to fly at 100 miles, not 300. And I think the saying then was, if you want close-up pictures, you got to get close up. And that was the idea. So all of this is described in this video if you want to look at it. But now for a couple of interesting things that happened in Corona. One is after we got it flying and we were a success, which means 15 flights and up, maybe 20, flight number 20. The normal routine was to issue a command from Vandenberg that just as it goes over the horizon, you're going to come next pass or so, we want you to drop down, and my stabilization was designed to release it correctly on time and so forth, so that it would land within a mile on the Earth of a location. And ironically, this Loran targeting to meet it on the C-130s was using Loran, as a matter of fact. It was very successful to get us in the same area. It wasn't a precision system like I'm talking about. But anyway, this went on and worked very well, except for one time. They issued the command to come down, and they weren't sure it got through. There wasn't a good lock on ensuring reception. So they issued the command again. So what it did was do this. It flipped it 180 degrees. So instead of going to Hawaii, it went over and landed at Spitsbergen. And everybody, at that time, it was a highly classified thing. We were worried, A, is this the start of a real Cold War turning hot, or what? And of course, at that time, they had a security guy, Colonel Moose Matheson, got a C-130, put some skis on it, filled it with GIs and guns, and landed in Spitsbergen. And he was a character going all over there looking for it. They never found anything. They're not sure whether it was found or not. But it was an interesting thing. This actually demonstrated if you can bring a nose cone by command with just the final trajectory in, it's a different ballistic missile program and a lot shorter time. You don't get Midas working because we're not launching any damn thing. We've got them stored up there. Anyway, it's an idea of thinking now you're turning military. We were thinking reverse. We didn't want to start anything. Anyway, I don't know. That's probably random enough.
I think